Good morning or afternoon or evening, wherever you are. Thanks for joining us. The focus of today's webinar is going to be automated aerial reality capture workflows. I'm Mark Goldman. I'm the Director of AEC Industry Solutions at Esri. With me today is Jeremiah Johnson. Esri is expanding into the AEC industry. It just makes sense for us to have solutions that include digital twin data. And a critical part of digital twin data is reality capture information. One of the solutions that addresses this need for capturing digital twin information optimally, organizing it, storing it, processing it, one of the solutions at Esri is SiteScan, a solution specifically for automated aerial reality capture. SiteScan, it's a cloud-based solution. It's an end-to-end workflow. It's for capturing and processing drone captured imagery. It integrates with BIM 360. I'm going to hand this over to you, Jeremiah.
Thanks, Mark. Pleased to meet you all. I'm Jeremiah Johnson. I'm an imagery solutions architect within the global business development team here at Esri. And one thing that I wanted to talk about is one way we can do reality capture workflows, and that's through drone workflows. So drone workflows are something that I specialize in. It's an industry that I've been in for a few years, and I kind of want to show you what Esri is doing in this space and what our customer is doing in the space. So a little bit about what we call the drone collections. One thing that we realize with our customers is that as reality capture is becoming more of a reality and some of our customers are implementing drone workflows, there's a growing need for complete end-to-end workflows. Everything from planning the flight, executing, processing data, and then dissemination on the back end. For a while, this has been a piecemeal workflow. But something that we've created are drone collections, and that's kind of what I wanted to introduce today. But these are some of the industries that are coming to us asking for these workflows. Obviously, we're going to be AEC focused in this presentation, but I did want to show you some of the other use cases that we're seeing. These are kind of our big six that have come to us, and we've been supporting with some of our drone collections. For the AEC specifically, some of the big ones are just regular site surveys, being able to get the latest up-to-date maps and models on any given day or week. Project management, being able to manage projects more efficiently and remotely using reality data. Drone fleet management. So this is a really big one as we are seeing increased uses of drones and pilots, and drone hardware is being purchased, and we need a management system behind all of that to assist the tracking of all of this. And then compliance monitoring. We're seeing growing use cases of, now that we have this information, how do we measure compliance? How do we keep a historical record of things that we've done on a project so that we have the data in case any litigations come about at the end of the project? These are the 4 drone collections. They're kind of separated into offline and online drone collections. So the 2 on the left, the drone mapping collection and the drone mapping and analysis collection, these are offline. So these are powered by a drone processing engine we call Drone2Map, and this is a Windows-based desktop software. And this is great for obviously disconnected environments or for organizations who are just getting started in drones and maybe have a single pilot or 1 to 2 drones, and they're just getting started. This is a great inexpensive way to cut your teeth on reality capture workflows using drones. The 2 on the right, the online drone mapping collection and the enterprise drone mapping and analysis collection, this is when you've proven out a drone workflow, you have the ROI, and you want to scale out. So you want to put a drone on every project, or you have several pilots and several drones. And this is where some of that fleet management comes into play. This is where you want a cloud-based scalable processing engine. And these are the things that we offer in the online drone mapping collection. The online drone mapping collection uses SiteScan as its processing engine. And some of you might be familiar with SiteScan for ArcGIS, but for those who aren't, it's completely cloud-based. It's an end-to-end cloud-based solution. So it consists of a few different components that we're going to walk through here in a second. But the main value prop is that because it's cloud-based, the data gets processed a lot more quickly, and the data is immediately accessible to the organization just because everything's already in the cloud. Benefits of SiteScan for ArcGIS, we're working daily trying to reduce the capture time. And capture time here, obviously we're reducing traditional methods, but we're also reducing drone capture time by implementing better drone workflows, better flight plans, and better situational awareness for the pilot. enhancing data accuracy using ground control points, auto-tagging ground control points so that users don't have to find the GCPs and photos and tag them themselves. Reducing operational costs, improving safety and productivity. These are some of these big factors that businesses are looking at when they're implementing drone workflows. So just a little bit about SiteScan for ArcGIS. SiteScan for ArcGIS, like I said, is a key component to the online drone mapping collection, and it's based on a few different components that I'm going to walk through here. You have the plan and capture component. This is an iPad app that connects directly to a variety of DJI and non-DJI hardware. And this is a drone mapping flight planning tool that you can use to create 2D and 3D flight plans. You can also ingest data from ArcGIS Online or BIM 360 to help you create better flight plans. And it's also a field data management tool. So it handles all of the image organization after the flight so that you don't have an SD card full of 3,000 images that you need to figure out how to organize when you get back to the office. Once you've collected all your data and you uploaded them into the cloud, we have the SiteScan for ArcGIS Manager, which is a web-based application. And here you can see the results of your process data, you can see historical data, and you can do analysis like time-based analysis, volumetric reports, inspection, things like that, all within the web browser. We took a lot of the workflows that our AEC customers are doing on a daily basis and simplified them, automated some of them, and put them in a web format so that you no longer have to download gigabytes of data just to open it up in Civil 3D and run a simple volume tool. You can do that all in the web now, and you can save your Civil 3D cycles for more Civil 3D focused tasks. The dissemination and collaborations, while we do have a lot of analysis tool in the web, we realize that you can't do everything in the web. And so we've made it easier than ever to be able to take these large data products from SiteScan into the data products that you're using. So a one-click button press to ArcGIS Online or ArcGIS Enterprise, as well as a one-click press into Autodesk BIM 360 for any of your Autodesk workflows. Let's talk about the iPad application. This is an app that's available on the App Store. It's built on the ArcGIS Runtime SDK. Drone agnostic workflows is something I want to point out, and let me explain what I mean here, is that a lot of times when you're planning reality capture flight plans, the overlap, the side lap, the sensor, the lens, all these things that you have to take into account when planning a reality capture flight, it's important. You want to get the right overlap, side lap to create a valid model. But what we've done is we've tried to simplify that so we immediately read the information from any connected drone and update and change the flight plan so that the number of images is correct, the overlap and side lap is adjusted and corrected. So what this means is that the user never has to worry about what drone is connected to the iPad. It's drone agnostic. So all they have to do is define what they want to capture and plug in a drone, and our software figures out all of the math behind it and creates the right flight plan for that drone. What this means is that, a lot of sites, they do reoccurring flights. So they'll fly every week, every month. And no matter what drone you have on site, you can just plug the iPad in and hit refly. And it doesn't matter if it was a Trees 200 or a Mavic, you can just hit go and it will automatically adjust for that vehicle and sensor and lens to have the correct flight parameters for that project. Like I said before, it's a field data management platform. So because you're flying all of your flights with the SiteScan flight planning app, it knows which photos were taken for which flight. So you can do a series of flights on a project, you can create panos, you can do various inspections. And then when the drone lands, you can transfer all of the images from all of the flights directly to the iPad. And the iPad will automatically associate those images with the correct flights. So it'll take the Pano flights and put it in the Pano project. It'll take the crosshatch flight, the images, and put it in the crosshatch project. It will do that automatically, so you don't have to worry about that when you get back into the office. Another thing it's doing automatically is tracking the fleet. So it's tracking what pilot flew what drone with what battery for how long. And it's automatically saving all of that. And as soon as the iPad has Wi-Fi, it's going to be uploading that data to the cloud so that any SiteScan administrator can see exactly what drones have flown where and for how long. It serves as a great source of record for all of your flights. A lot of times organizations have insurance or legal requirements that make them want to keep track of all of this, and SiteScan makes that really easy by just handling that automatically. Something else that insurance and corporate likes to see is organization mandated pre-flight checklists. So in addition to the pre-flight checklist that the app automatically goes through with the aircraft, administrators can define a pre-flight checklist for the pilot to go through and select custom questions, multiple choice answers, free text answers, and deploy that across the organization so that any pilot who's about to take off with a company drone has to fill out the questions that the company has put in, such as, did you submit the FAA paperwork? What is your pilot number? Did you go through the da-da-da-da to take off? Whatever the organization wants to put in, they can and enforce that across the organization. The flight planning app is great in that you can pull in 2D and 3D data to plan your flights. So here I'm pulling in a mesh of the city of Toronto, and you can use these 3D data points to plan flights. So a lot of times the best way to capture a building or a tower is to fly what we call a perimeter scan around that. And so you define the region of interest and you define the height, and the drone will fly multiple tiers around that object. And it's a lot easier to plan this type of flight when you can pull in 3D data, whether it be from BIM, Revit, or ArcGIS Online, in order to make better flight plans. Once you've taken off, you can actually view the flight in 3D. So here you can see the drone camera on the upper right as it's flying. You can see that I can pull it into 3D and pan around the drone as it's flying. This gives the pilot great situational awareness. So if you have those 3D scenes, those BIM models, you can see exactly where that drone is in relation to tower cranes, neighboring buildings, terrain, things like that. Once everything's captured, it goes up into the web, and this is a screen capture of SiteScan Manager. So SiteScan Manager we think of as a complete analysis and collaboration tool. So it allows you to add users to your project, users who want to view and edit the project or just view the project. Administrators can select who can do what through an admin tool. We have a direct integration with ArcGIS Online, ArcGIS Portal, and Autodesk BIM 360. I want to talk about BIM 360 for a second. So you can actually link your SiteScan account with your BIM 360 organization. And what this means is that if you have PDF plans, other overlays that are saved in your BIM 360 docs, you can pull that into SiteScan and do QA/QC with the BIM 360 data draped on top of your reality data that was captured by SiteScan. And this makes it really, really easy to have single source of truth for all of your designs and your drone data. Once a plan has been updated, all you have to do is hit a refresh button. It's going to go grab the latest version of that file, and the overlay stays overlaid. It's just the updates get applied. We also have a field reporting tool within SiteScan that allows you to submit BIM 360 field issues or RFIs to BIM 360 directly from SiteScan. As you fly a site over and over, especially during the earthworks phase, it's important to create regular volume reports and inspection reports. You can select an area and it'll kind of dive through each flight that's taken place over that area and will generate the PDF report for you showing the change in volume over time. Something else you can do is pull in your surface data as land XML files. And here you can see I'm pulling that land XML file in, and it's going to show my drone data in blue and then my land XML file in yellow. And you can see exactly where the drone data is versus where I am having to cut into. And you can use this just for visualization like this, but you can also use this for all of your volume tools. So you can see exactly where your current surface is compared to your design surface, and it just makes planning that much easier. This is a visualization of what I was talking about before, being able to pull in CAD files. Here I've loaded a DXF file, and I have full layer controls on the left-hand side. So any layers that I have saved in my file, I can turn on or off. You can see it saves the color and location of that data. Now I kind of want to show what our customer has done with this tool. So we have a customer, Skanska, and has a project in Norway, the west coast of Norway, called the Nordavegan project. And what this project is an infrastructure project that kind of hugs the west coast of Norway. And they're using drones pretty extensively on it. And I kind of wanted to show off what they've been doing. So this is kind of a map showing just this part of the project, connecting 5 islands. These 5 islands were previously only connected to the mainland via ferry. They're building a highway infrastructure through it. It consists of bridges, it consists of tunnels, and it consists of 2.5 kilometers of ocean fill, so dredging and creating artificial islands for the road to be built on. And for a lot of this, it's really, really difficult not only to traverse between different parts of the project just because there are 5 islands, but it's also just difficult to see the scope and see progress of a project like this without having a constant, up-to-date, top-down view and 3D view of the project. So they were telling me it takes about 10 hours to go from the mainland to the furthest island. So you can see that site visits are just really, really painful. And their main office is back on the mainland. And so anytime any of the head surveyors or planners want to go and see the site in real time, it takes a long time. It takes a couple days to be able to do this. So what SiteScan enables them to do is they can have their folks on the different island projects flying the drones constantly and feeding updates to the main office. So these are some of the highlights that they brought up, and one of them is being able to measure difficult areas. There are workflows that were previously done by laser scanners that they're now able to automatically do with drones, and one of them is being able to measure cliffs like this. Collecting more data is a lot easier. It's being able to fly is a lot simpler than trudging around a total station or a LiDAR scanner. And being able to QA, QC everything. One of the things that they brought up is that when they're on site and taking pictures of things, they have to know exactly what they're looking for in order to measure it or take a picture of it. But when they're capturing everything with drones, they're able to just capture everything. And even if something pops up that they didn't expect, they can always go back to historical data and see changes or measure differences that way. Being able to overlay their documents on top of the drone imagery allows their project engineers to better QA, QC the data. They're able to see exactly where the ocean fill is being put in the correct location, and then the bridge support systems making sure that they're being put in the correct way. Data management, being able to have everything in the cloud just makes it easier. There's no longer files that are stored on somebody's desktop that if you want access to, they have to upload to FTP. Everything's in the cloud, whether it be their CAD drawings in BIM 360 or their reality data in SiteScan. So anybody, anywhere within the company has immediate access to this data. Something else they're able to do is add the client in as read-only accounts so that the client can see the progress up to date, and they are able to build a stronger client relationship using that, being a lot more transparent with that data. This is an example of some of their data flow. They're using SiteScan for ArcGIS as their main data hub. They're both collecting and storing the reality capture data in there, and then they're using the connections with BIM 360, ArcGIS Online, or just straight file downloads from SiteScan in order to push to more advanced workflows. So they have a web viewer. They're able to immediately publish their orthomosaic to their ArcGIS account and have their local intranet web viewer update with that web scene. They're also able to pull this into Gemini or Civil 3D as a point cloud. Something else that I don't have here is a Navisworks workflow, being able to publish the point cloud directly as a service to BIM 360 enables Navisworks to go out and grab it, and they're able to do clash detection with Navisworks that way. Within BIM 360, they're able to publish the 3D mesh and point cloud into the large model viewer and be able to view some of that data in other Autodesk products. And then ArcGIS, being able to create 3D scenes using point clouds and orthomosaics, using ArcGIS Pro and ArcGIS Online to distribute that information. This is a screenshot just showing a better, clearer view of the Navisworks clash detection workflow. So what you're seeing here is the reality data point cloud that you're seeing as the rocks and ocean that you see there. And that was taken, processed with SiteScan, and then published using the BIM 360 connector. From there, they open up Navisworks and pull up the 3D model and then import the point cloud from BIM 360. And here you can see the overlays showing exactly where things are and then where things are going to be. A key component to this is being able to collect ground control points so that the resulting drone data is in the exact same coordinate system and has the accuracy required in order to do this. And what they've done is actually taken chevrons or X's that are kind of spray painted across the project. And in some cases, SiteScan can automatically detect those and auto tag the ground control points so that the resulting data products are accurate without a whole lot of manual intervention. Something that is just coming about is being able to implement a lot of reality capture workflows within ArcGIS Online. So here we have a screenshot of that same project using Revit data and SiteScan data within ArcGIS Online. So a lot of the same workflows that folks are using Civil 3D or Navisworks for, they're also able to use ArcGIS Online for. It kind of depends on where the data lives and how you want to share the data. One of the benefits of sharing in ArcGIS Online is that you're able to create public web portals and dashboards that the public has access to. And this way you can show progress updates, you can control what's being shared, what stage of construction is being shared that way pretty easily. But within the office, you can do things like this. You can slice through the data, making sure that the surfaces is being created the correct way. You can do your volumes, you can do line of sight, you can do all of these other GIS-based 3D workflows using a lot of this data. That's the end of the SiteScan portion. If you wanted to learn a little bit more, visit this website.
Great, Jeremiah. That was wonderful. Questions came in. How are the photos being uploaded to the cloud? Does SiteScan skirt the need for SD memory on the bird by storing the photos on the iPad?
That's a really great question. The drone, as it's flying, it does need an SD card. It's just a limitation to the camera. So the drone is either in capture mode or in SD card mode or read mode. So as it's flying, it's capturing the images. Unfortunately, we can't grab those images live. Grabbing the images happens after the drone has landed or after all of your flights have been completed. Then you can do the image transfer over to the iPad. So you do still need the SD card. However, we've tried to make it as simple as possible where you're not having to rely on taking that SD card back to the office to transfer back to your desktop computer.
Question from another attendee, Tom asks, do the system take drone regulations into account when mapping flight plans? And he mentioned specifically, certain cities have stronger and higher regulations than others.
Yeah, great question. With Esri being a global company and this being a global product, it's hard to satisfy every federal and local regulation. However, we do partner with a company that will allow you, at least in the United States, to be able to submit LANC authorization. So it'll show you if you're in a United States controlled airspace and will allow you to connect your flight plan directly with their service, be able to submit a authorization to fly there. That is US only, but if you are outside of the US, what we've been seeing users do is being able to pull the GIS data from their region's federal administration and pull that in as a GIS overlay. And so immediately when they're opening the flight planning app, they can see those overlays and they can see where the controlled airspace is.
Here's a question that you're going to have to translate for us non-experts. Does SiteScan do PPK or RTK processing? And how is ground control managed?
SiteScan does a lot of the flight planning and processing of the data, but it doesn't do the GNSS corrections like RTK or PPK. That being said, we do support drones that have RTK and PPK solutions enabled. So if you have, for instance, the M210 RTK or the Phantom 4 Pro RTK, you're going to be using the DJI app to set up the RTK portion of that collection. So you're going to set your base station, you're going to set your VRS system, however you're going to be correcting the images. And then as the drone is collecting data, it's automatically going to be writing the correct GPS locations into the EXIF of the image. And then when you upload, obviously SiteScan is going to read the EXIF data on the image and will produce RTK corrected data. Same goes for PPK, depending on the drone manufacturer. They have their software to do the post-processing of the GPS. And then there's an option when you're uploading those photos to SiteScan, you can define the accuracy, the X, Y, and Z accuracy of the EXIF information on the images, and that's how we will process that RTK and PPK images. You asked about ground control points. The ground control points workflow is pretty simple. So you take a CSV file of survey points and you upload it to SiteScan. And if you are using your common checkerboard, your white and black checkerboard or orange and black checkerboards, SiteScan will automatically look for those and try to tag the images for you and automate a lot of that workflow. But they don't have to be those checkerboards. You can use marks or X's or manhole covers. Just know that SiteScan will automatically look for those. You'll have to go in and tag those yourselves. And tagging just takes an additional 5 to 10 minutes to do. And then when you process, it's able to apply those corrections from the ground control points to the resulting data products.
What are our plans? I don't know if you can talk to this about VR and AR for field work as it pertains, I guess, to SiteScan.
The intersection point is going to be on the back end. So after the data has been processed and uploaded into ArcGIS Online, you can use some other existing Esri software technologies in order to create that VR workflow. I don't know if there's an AR workflow just yet, but being able to view the scene on a mobile device and virtually look around a project or go into VR and look at that, that is a workflow today. It's just not a fully SiteScan workflow. You're going to have to implement some other Esri software in order to
Sure. Okay. Let's see. Question: can the flight plans be imported into ArcGIS as a line feature?
When you're doing the ArcGIS Online connector piece, so after a flight is completed, you're publishing all this data to ArcGIS Online. There are a couple of other data products that are not point clouds or orthos, and they're related to the flight and where the images were recorded. I'm not sure if we publish the exact flight path of the drone, but you can import the photo locations and use the point features to line geoprocessing tool to create that flight line within ArcGIS.
Question is there a large team investment required to get the most out of this, or do you know of examples where projects smaller than Skanska, smaller than connecting 5 islands off the Norwegian coast?
Great question, and it's something that I thought about when putting this presentation together, is that they are using a lot of tools in order to complete the workflow. It's a great way to talk about how the drone data can go from one tool to another, but it didn't have to be like that. We definitely have projects and customers where the drone pilot, that's not their full-time job. They're a survey guy or a planning guy that just happens to be out in the field with a license to fly the drone, and every morning at 8 a.m. they go out and press go and collect the data for that day. Since everything else is automated, the SiteScan workflow is pretty simple. You can view the data, you can look back at the data, and you can do volumes and heights and distances and overlays, and for a lot of people that's it. That's where the workflow ends. But if there are civil engineering folks who want to use that and they're not familiar with SiteScan, they don't need to know about SiteScan. The person running SiteScan can just publish to BIM 360 or just download the data products themselves, and those data products can just jump right into Civil 3D or Navisworks just because they're pretty generic file formats. It's able to be pushed into those solutions.
Cool, great to hear. I'm glad you touched on that. Question here from Scott, 2 questions actually. Are you able to produce thermal point clouds? That, I guess, would be dependent on the drone.
Yes, it is dependent on the drone. We do support 2 or 3 drones that have thermal capabilities, and you plan your flights anyway, just the normal method. The overlap and the side lap is going to be a lot higher when the software recognizes that there is a thermal camera attached to the drone, and that's just because it's a requirement for thermal data. But the resulting images, it's just like any other image. They're geotagged thermal imagery, and it gets published and processed into thermal ortho and a thermal point cloud. Note that the point cloud will not be as dense or as high resolution as some of the color, RGB point clouds, just because thermal sensors are not as high resolution as RGB cameras today. RGB cameras today are 20 megapixels, thermal cameras today are 3 to 5 megapixels. So it's not going to be as dense of a point cloud, but it will generate a point cloud. I recommend using them more for orthomosaics than point clouds.
Okay. That's it for this webinar. Thank you for your time.